Welcome, everybody, to the American Space Museum. I'm Marquette, and we're so glad you're with us today to stay curious. Today we got Terry White with us. Terry, of course, manager of the orbital processing facilities, the garages of the shuttle. Hey, Terry, how are you?
Doing good. How are you?
Well, we're glad to have you back. Your handshake's getting firmer there. You're getting better health. He had a couple little minor surgeries that we're glad he got over. And once a month, we have Terry come and talk about a shuttle event or shuttles of the month of March. Today, we're going to talk about what you consider the first real return to flight.
Yes, STS-2. It's the first time in the history of mankind that we launched a vehicle into space, STS-1, and then brought Columbia back, and we were going to send that same vehicle back up to space again. So that was the true return to flight.
Terry's going to tell us about some of the challenges of that. And of course, the shuttle was built in the 1972 era of the Nixon administration to fly 3 or 4 times a month. And here, the first flight in April of 1981. And we're going to talk about that, servicing it and getting it flown 7 months later in
Correct.
November.
Yep.
So
yeah, it was a challenge because first thing we had to do was a lot of inspections, but it had landed in California. We started checking it out there. Then they had to get it on top of the 747, which had been done before, but then bring it back to Kennedy Space Center, get it off of the 747 and take it into the hangar. And in those days, we only had one operational hangar, which was Orbiter Processing Facility number 1.
all right. Well, we're going to talk a little bit about that process in here, and we hope that you enjoyed our program about building a shuttle with Gary Allgaier. We have our 50-some images on that show, and it went kind of long, but we got only half a dozen pictures or dozen so pictures here to show you and listen to what Terry's got to talk about it. But before we get going too further, I want to bring on 2 of our friends visiting us from Michigan, Larry Pushkar and Dave Stange. And you all have met these guys before. Come around here, guys, all right? Yep. There's Larry. Great to see you, Larry Pushkar there, and Dave Stange there. Marty's going to pass out there. You've seen them commenting names on there, and you saw a beautiful launch today.
Yes.
Of some satellites. Guys, you found Stay Curious. You know, Marty and I've done this 3 years in a couple weeks. Unreal. And you're some of the newest ones to find us, and tell us about that.
Well, I had visited the museum about 4 years ago.
Lean forward there over him.
I visited the museum about 4 years ago, and I started following it on Facebook. And one day when I was on furlough during COVID, it popped up that there was a live broadcast being sent out from the museum. I said, well, I gotta check this out. And I've pretty much been hooked ever since. I got Larry on board shortly after, and we're your Michigan connection.
You are. You're both wearing your Chris and Callie T-shirts there. Of course, they're from Michigan. You know, we do kind of get some chilly days down here.
I knew this was coming.
So I had this blanket here to keep me warm, folks here. So.
And I didn't wear my Michigan hat
right,
just to be nice.
Well, I said to pull that on. I did bring my hat here, though, because it gets a little chilly in here. So in there. But
Wow.
So they're from that team up north, as we say, from Ohio State there. But no, truly, and Marty, I'm sure I'm speaking for him too, having people like you that have enjoyed our programs for 770 episodes we're staring at here. March 23rd, 2020, born out of the pandemic. We thought we were going to be an alternate for school virtual tours, you know, day trips and stuff virtually. And people in the Space Gate community found us. What do you got to say, Larry, about Stay Curious and your interest in space?
We've always had the interest in space, and having been to a couple of shuttle launches, and then Dave told me about the podcast, and he says, you got to watch these guys. They're really something. And so we started watching them, and then watch them at home, and then I go up to my father-in-law's cottage up north in Charlevoix, and then up north we got everybody watching them with us as we sit on the beach and watch the program, and we just feel fortunate to be able to come here and tour the museum, and I really want to wear the John Glenn hat.
Oh, do you? Yeah, there you go. It's in the case there. Wink, wink. I don't have the key to it, actually. Joe, would you take a picture of us all here with your phone, or Marty, you grab yours and take it there before I usher them off here and talk, because it's people like Terry White sitting here who I knew nothing about. He was until a little over a year ago, so forth. You're the kind of people, Terry, that has hit the heart and soul of people like Larry and Dave here, I think. Am I correct about that?
Yes, sir.
Because we truly feel we provide people and entertainment in a way about the shuttle era like none other. And that's because people like Terry are willing to be here. We've got Gary Allgaier was here, and Gary Studi this week, a plant expert. We just lost Hugh Harris, but boy, did Hugh really enjoy it.
He
Age
was
90,
a great guy.
being on our program. So, this is what we need, is more people like you to watch our programming. If you can't see it every day, that's fine. But, when we have A-list people like Terry here, who you're going to hear things about the shuttle that you won't hear anywhere else from an authority who lived and breathed it. And Terry, uppermost, I know in your mind, was of this orbiter keeping our astronauts alive and bringing them back safe, right?
Yep, getting the ship turned around from one flight to the next, making sure everything was working fine to take our astronauts into space, accomplish their mission, and especially bring them back home safe.
Sweet.
All right.
Well, Larry Pushkar,
Thank
can't
you.
thank you enough. Dave Stange, they're great guys.
Thanks for having us.
Yeah, thanks for having us.
We're going to usher them off stage here and kick it off here about STS-2, which was a November mission. However, we do talk about the shuttles of the month of March. We've had so many guests, we've never not really sunk our teeth into it yet this month. But we got 10 shuttles, all the orbiters Terry flew, but Challenger. And we had really 59 human beings were launched. All right, 51 were women, 8 women. March is Women's Month, and it's also one of the months where the most women flew in space on our beautiful shuttles there. We're going to talk about Columbia today. Columbia had 3 shuttle flights in the month of March. So did Discovery. Atlantis and Endeavour, just they had 2 each, and like I said, O99 Challenger didn't fly at all. Of course, it just had 10 missions in its history. So Terry, I'm going to be quiet as we show it's the 22nd anniversary of the launch in November. All right, and STS-1 came back in April of April 12th. 1981, did 3 orbits of the Earth with John Young and Bob Crippen, and there it is landing out at the Edwards Air Force Base.
And since it was the first flight, it landed on the desert. So you can see it kicking up all the sand when it landed on the desert, and it did a lot of damage to the tile when those little rocks came up and hit the tile, especially on the body flap and after the main landing gear doors, which you can see in the photo there. So,
And you're going to talk about how some of the damage that incurred on liftoff. Really, none of it would have occurred in space, I guess.
Well,
Liftoff and landing.
yeah, some of it, but the majority of it, because we discovered prior to STS-1 that we had a problem with the tiles and they were not going to adhere. So we had to take the tiles off of Columbia, harden them, and put them back on. Well, Columbia had almost 32,000 tiles on it, and we did not get them all removed and hardened and reinstalled or replaced. So when we flew STS-1, we lost some tiles at liftoff on the pad, and then we lost portions of tiles at different times during the flight. But so it was something we knew was lingering there. So it was the lower temperature areas up on top of the crew module, back on the orbiter maneuvering pods, and areas that were not quite as critical, but we had hardened the entire lower surface. But we did lose tiles, so we had to replace quite a few tiles when it came back, and then we had to sample tiles. So there were tiles that were good that we had to go take them off so we could see what the structure looked like underneath. We had to inspect for hydraulic leaks or other types of issues that could be with the aluminum structure. So there was a lot of work involved with that, and we had to inspect not only each one of those tiles, but we had to inspect the gaps between each one of those tiles with a magnifying glass and a high intensity light looking down to see if any heat had actually got down the sides of the tile. So yeah, it was very extensive. And then we had to come up with some new repair procedures because some of the things we opted not to remove the tile for. And it's not just the tile, there were other things on the vehicle that we found that didn't perform exactly the way the designers and the engineers wanted it. So we had to come up with new repair procedures to go do that. But as well as on the outside, which is what I was responsible for, and STS-2, I was responsible for the forward section, everything forward of the payload bay doors, which included the crew module, the forward reactionary control system, the nose landing gear doors, because it was such a vast amount of work that we split up the orbiter into different sections for different crews to work on. But yeah, so
We'll move that center here so you can turn that around and show people. After the landing, of course, was the first ever processing of the and we've done a few Stay Curious programs, and now we got Terry on board. We'll talk about these toxic fumes. You can't believe the invisible aura of fumes and stuff being off of this thing, right, Terry? But all of this, we have to emphasize, first time ever, all right? And to go from the drawing board, to the reality of it, this is where the rubber met the road, and where you learned a lot, right, Terry?
correct. So post landing, we're sitting out there on the runway, or in this case on the desert. We have to go out there and sample to make sure none of the hazardous chemicals and the fuels and oxidizers that are leaking, so that people can actually go out to work on it. So we have a special crew that goes out in special suits, and they go out and sample, because inside the orbiter maneuvering system, you have the fuel and oxidizer tanks, and up in the forward reactionary control system, that they are extremely hazardous. So once they make sure that though there are no leaks, it's not going to harm anybody, then we're working on getting the hatch open to get the astronauts out and that. But as you can see on the screen behind me, we have to hook up the air conditioning system, coolant, to keep the orbiter cool on the inside. Especially the astronauts up there want the temperature to maintain cool. But then we have to hook up all the communications. So yeah, there's a lot of work that has to be done, and that stays connected all the way in till they get ready to made it to the 747.
Well, of course, the idea was to get this bird back up again, and of course they did successfully. The launch in November 1981. The exact date, November, what was that? November 12th. Yeah, November 12th, 1981. The white tank, we're going to talk about that. 2 shuttles launched with the white external tank. Of course, the astronauts on board, we can't forget about them. There is Joe Engel on the left, Richard Truly on the right. They were partners on the approach and landing tests that were the glider tests off of the 747 carrier. Joe Engel on the left there would have been a moonwalker on Apollo 17 had he not been bumped for the first geologist on the moon, Harrison Schmitt. And then, Joe Engel said, well, we're no more Apollo missions. You're not gonna be able to go to the moon. So what do you want to do? We'll let you go on Skylab, or we'll let you do the Apollo Soyuz test project. And Joe Engel said, I want to fly a plane, a space plane. And he did. On this mission, became the only human being still to fly 2 space planes, because he was an X-15 pilot.
X-15 pilot, and then flying the space shuttle.
And here's his handprints. Of course, we brag about that the American Space Museum founded with handprints of astronauts in bronze. There are his. His hands are pretty normal size. Joe Engel's are a little on the small size there. There's Richard Truly, and then, of course, he flew STS-8 after this for his second flight. I believe we had Engel, flew 2 flights also. Truly flew as a commander later on there. So you mentioned about putting the bird on the shuttle carrier transport system there, a souped up 747. I wanted to give a shout out to the pilots of that, who you said that you've met before. Left to right, Tom McMurtry, pilot, Vic Horton, flight engineer, Fitz Fulton, command pilot, and Ray Young, flight engineer. And there's people out there like you that might collect their autograph as a kind of a hidden thing. Move the shuttle a little bit there. Oh, there we go. Okay, Marty's checking that out there. You can set it on there. Give your little height there for you, my friend. Here, get it out from under that light. There you go. Okay. And we got the connection to the microphone.
Okay.
Great. So I just wanted to, you want to talk about putting that on the S747. I wish I would have seen it flying. I know that when it come back from California landing, which was a weather issue there in the last third of the flight, to see it fly up the coast here and signal that I'm back.
Yeah.
Everybody get ready for
And
me.
generally they would do that. They would make a flight down the beach and down the river when they came back so that the
Wow.
people around here could see it. And as they ferried back across the country, a lot of people got to see it flying across, Colorado, Texas, Arizona, all the way up into Kentucky. So depending on weather, they would fly around the weather to get it back here.
$2 billion national asset there. Good that we could see it. Some of you did. A question, Marty.
Yeah, Dano Demano, what is the greatest damage that you have seen post-flight?
The greatest damage to
An orbiter post flights.
to tile damage, we've had impacts that knocked holes in several tiles that we could actually see the green structure underneath. But the adjacent tile material did such a good job that the astronauts did not have to go do any on-orbit repair. So the orbiter came home just fine. We figured we'd have to do structure rework when it got here, but it hadn't even over-temped the paint.
Mm-hmm. Yeah, it's very resilient in many ways. A close call was STS-27 when a burn through almost occurred, but it was over a heavily structured part of the
Yeah,
burn
and
pit.
it actually burnt through on the Elevon.
Yeah. And there are several close calls there, and then you can talk about the SRBs being they're compromised on there. But we're going to get this. Terry's going to tell us about the 7 months that it took to this point, the rollout at night under those beautiful xenon lamps to get the bird back on pad 39A.
Yeah, so as well as inspecting the outside and removing and replacing a lot of tiles,
There you go.
okay, then we had to, like I said earlier, we had to do a lot of repairs on tiles, but we had different portions of the thermal protection system that we had to take apart and actually remove from the ship to make sure that it functioned properly in that. So that was a lot of work, especially around on the lower surface around our landing gear doors. So they have a seal just like your refrigerator has a seal, only this is a high temperature seal that goes around there, and it is really critical in that. But those were long processes to get all of those taken off, get all the tile that were impacted by that taken off, and then on the inside we had to go inspect in the payload bay. We had to go inspect everything in there, and people don't realize the miles and miles of tubing that's associated with all the fluids in that go through there, all of the more than 200 miles of very critical fragile wiring that's in there. We had to take apart a lot of things inside the crew module, inspect all of that, and start putting everything back together again, and then starting to install the payload for STS-2. We had to take and inspect all the different systems of the fuels and that. And these systems that have the fuel and oxidizer for maneuvering the orbiter when it's in space, they actually are designed to come off of the vehicle. And when we're doing the real hazardous work on those, we take it to the Hypergol maintenance facility, which is way out in the boondocks. So there's very few people around it when they're working those really hazardous.
And that's this OM pods on each side come off in there.
Yep. Yeah.
And this is important. This is the main maneuvering system in space because there's no fuel for these three engines
Yeah.
anymore.
The three main engines run off of the big external fuel tank. So once it's emptied, they're just ballast now. They don't provide anything, but the two smaller engines do, and they're really critical for when you want to come home. So you're flying backwards, you burn those for a few minutes. It slows the orbiter down from 17,000 500 miles an hour to 17,300 miles an hour. All you have to do is slow down 200 miles an hour, and then that force we call gravity starts bringing you home.
And they start that about 3/4 of the way around the world from where
Over
they,
Western Australia, and 45 minutes later, you're landing at Kennedy Space Center.
there you go. But the first time we did this, Terry, I know NASA's got all kinds of manuals and procedure things and so forth. Just how smooth was it, or how did you have to rewrite a lot of procedures?
Again, this wasn't something that anyone had ever done before. They had written procedures, but we come against stumbling blocks in performing some of those procedures, so we had to rewrite them as we went along. And something I enjoyed was because I worked with some guys that had worked on the Apollo spacecraft before, and we would find something, they'd say, well, we never found anything like this on ours, and I'd have to remind them, because you did not get your spacecraft back. The only thing that came back was the capsule, and it never came here to Kennedy Space Center for them to look at that. But we would find something, they said, this one wasn't installed quite right. I said, well, we get the option to see that now, but you never had that. So
What do you think was one of the biggest processing surprises of the whole orbiter?
well, the amount of damage at the tile, they weren't expecting that. The original designer said, you put the tile on, there's a few of them you got to take off periodically for inspections and that, but they're designed for 100 flights. So yeah, there was a lot of work associated with the tile. They didn't realize how long it would take, and just the other things associated with the payload and the other parts of servicing the orbiter. I mean, just to take the 3 engines out, which we did after every flight, you have to take off 200 panels to get access to take the engines out. Then we would take them out, send them to the engine shop. A few weeks later, when we'd done our other work inside the aft compartment, they would send us back 3 engines. So, and then we'd install. Now, once we got everything disconnected, we could pull 3 engines in a 24-hour period. And then when it came time to put them back in, we could put 3 engines back in a 24-hour period. So,
How involved were individual astronauts, either curiosity or wanting to be involved in this?
well,
reflight?
STS-1, Young and Crippen came around a lot because it was delayed for a couple of years. So they had done all their training, so they came down here, periodically and that. Now, after that, we didn't see a lot of them. Again, they do all their training in Houston, so there's only a few days of training that they actually do here. And like I said, we were very busy working on the vehicle and that. So when they came down, it was, you're not going to interrupt your work because they're here to do a job at that time. So there wasn't. Later on in the shuttle program, then there was more time where we would have events after work, and the crew would get to one of the local establishments, and we could go there and share pizza and beer with the crew and that. So
Was there pressure on your crew to work faster and get this turned around quicker?
they made schedules that were very hard to complete what they were asking for, because again, it's a whole new vehicle, and even the people planning your work didn't understand exactly what you had to do. But yeah, it was STS-2 was almost the entire flow. For me, was 12 hours a day, 7 days a week. So when we got all of the work done in the orbiter processing facility for my section of that and the rest of it, and we were shortly to go to the vehicle assembly building, they ran one of the elevons into the structure and damaged it. So we had to remove the tiles that were there and do structure repair. Now, we did not get the tiles put back on. So we had to install tiles while we're over in the VAB, and they finish them out at the pad, climbing up 7 levels of scaffolding because it was not designed to be worked on out there, to go up there and replace the tiles. So that was still 12 hours a day, 7 days a week, got all that done, had 2 8-hour days, and then we had a spill of oxidizer down the side of the forward reactionary control system. It did not hurt the tiles, but it turned the paint that the tiles were glued to back to a liquid. So we had to remove 380 some tiles out at the pad, and we did it without dropping a single one, 207 foot up above the pad surface, looking down another distance beyond that to the bottom of the flame trench. But yeah, so yeah, I was lucky enough that 2 techs and myself were the only ones qualified for the special breathing stuff. So we stayed up there all night long, taking off tiles and bagging them and getting them some special ovens to clean them and that to finally get off the next day when they got some other people trained. But yeah, so we put it all back together. NASA couldn't believe how quickly we got it back together, but they were expecting several months, and several weeks later said, we're done. You can fly when you're ready because we're done.
That's a good feeling.
Yeah.
Of course, the first 4 shuttle flights at Columbia were experimental test flights with 2 astronauts, even ejection seats underneath them. Then STS-5 was the first operational, so to speak, of it, though at the end of the whole program, they basically deemed it was experimental, all 135 launches.
Yeah.
So where did you kind of feel like you were in your stride? You worked out there 30 years and everything, taking 7 months to return a spaceship to space.
And it wasn't always us. I mean, there were challenges and different flows of what we had to do to get the vehicle ready, but sometimes we could have the vehicle ready and the payload wasn't ready.
Mm-hmm.
We had everything and it just wasn't delivered here and ready, so that stopped the flow until we got it done, but we still had work that we had to do as long as it was on the ground. But yeah, it was later in the program, the orbiters were flying so well that sometimes when we brought it into the hangar, we said, look, we can change the tires and clean the potty, and it's ready to go back up again.
Wow.
It was flying that well, and we had improved our processes and we're good at them, but the orbiters were doing an excellent job. So yeah, we learned a lot as we went along, and we learned even more that we didn't want the incidents we had, but we learned from them. So luckily in my world, nothing orbiter-wise caused the loss of the 2 vehicles we lost. It was external to the orbiter. So
Yes, and that included those beautiful SSME engines that never faltered in there. Did you find tools that need to be made or techniques that need to be altered, or there was a meeting that says, hey,
No.
we don't need to do this
No,
anymore?
constantly. And what we also found was when we got it back and had to work on it, the platforms that were designed were not designed to work on the vehicle. So when you went up to a place you needed to work, the platform was either too high or too low for where you needed. I mean, we had some tasks that you had to lay on your belly, head down over the rail, and work for hours on the windows and things, just things that made it very difficult. Getting it around inside the orbiter was very difficult. The structure won't support your weight. So we had a whole erector set of platforms that we had to put in so we could go do that. So it wasn't just a simple thing of pull it into the garage and now go out there and access it. No, you got to build all these things. So we had to go modify our platforms. And when we would roll out, we would have to go in there and have the ground crews come in there and modify these platforms that we needed to work. And at the same time, we were getting orbiter processing facility number 2 brought up online. So,
Well, it actually rolled out of the VAB August 31st, according to my notes. You had it out of the OPFs ahead of that time, of course.
Yep.
But it's out there from September 1st, October, November. It's out there almost 3 months.
and that was the normal
the
pad
normal
flow
pad?
for a lot of things out there, especially if there was a vertical payload, would be out there for a while. But yeah, it was, the majority of the work on the orbiter happened in the horizontal processing, the orbiter processing facility. Then we took it to the vehicle assembly building, raised it to the vertical, mated it to the tank, because the tank was already mated to the boosters, and we're in there 7 to 10 days normally, and then out to the pad, and we'd be out to the pad for several months.
That was originally going to be launched November 4th, 1981 at 12:30 in the afternoon. It ended up being, they had APUs, some sort of lubricant had to be flushed out of the gearboxes,
Yeah.
my notes say here. So, but really, to shoot for April 12th, it was a 7:20 a.m. launch. At 10:10 it actually went. I really find it quite amazing that you didn't have more delays, quite frankly. And once it got out to the pad, you didn't have 3 or 4 attempts there.
Yeah, we got through the spill, and then the the rest of the pad processing, getting it ready. And yeah, some flights you would run into hiccup after hiccup out at the pad, and for a while though, they called Atlantis the Penguin Orbiter
Oh, really?
because a penguin never flies. So no matter what went on, there was, there's a delay. It's not flying. It's rolling back. Yeah, they had all kinds of nicknames for them and that. But yeah, so just for a while for it to get back into stride and back into space.
Your 30-year involvement with the shuttle here, I've heard our Atlas unmanned rocket guys in our Cape Canaveral galleries say that, and they launched over 350 of these Atlas rockets, and they'd say when they get it from the factory, if it had few problems, and if they didn't work with it a lot, they didn't have a lot of confidence.
Yes.
If it came real clean and they didn't have to do much to it, invariably something would bite them in the butt, and they would fail. But if they really had to work with, he said, this is Murphy Wardman, who's 92 years old, telling me this a lot. He said when we had to really work with it more and more hands-on, it was a better mission, and we felt things flowed quicker.
Yeah. The hardest part of that for our vehicle was, we tried to keep the same people on the same vehicle, but we rotated them in and out. You may be working Columbia, and then the next vehicle you get is Atlantis, so we tried to keep crews in a certain orbiter processing facility and bring them, and toward the end of the program, we had 3 hangars and 3 vehicles, so we tried to always bring them back to that. But there was, like I said, modifications we had to do to the hangars, so we couldn't do that modification with the orbiters in there. So it had to be that time span when they're out at the pad, and then get them back for when the orbiter came back to the orbiter processing facility. And like I said, we were at the...
Well, there it is out on the pad in September area out there. The tail number of Columbia was OV-102. Total number of crewmen that it flew was 160. It traveled over 120 million miles in space. That's 4,800 orbits. 300 days exactly was its time in space before we lost it on STS-107, which was the 113th flight of a shuttle. And it's always mentioned, in fact, at the sort of wake for the astronauts as well as Columbia, that Bob Crippen was the main speaker for. He kind of joked and said she was a little heavy in the bottom, but she was a true matriarch of our proud shuttle fleet. But she was made heavier with a lot of instrumentation, correct?
It had a lot of instrumentation on board. And even when we quit collecting that stuff from the instrumentation, we didn't go remove all of the instruments. We had instrumented tile all over the vehicle as well. But we just quit collecting a lot of that. And then what was collected, even on this last flight, was stored on board the vehicle. So we had to find that OEX recorder in our searches through Texas and Louisiana to get some of that data. And in the picture, everybody says, well, why the white tank? Well, the tanks originally were supposed to be painted white, but we discovered that every pound you take into space is expensive. So we could save, I want to say 380 some pounds by not painting the tank white. So after that, we flew with its natural color. 600 pounds? Okay. I wasn't a tank guy, so I'll rely on Marty.
Well, we've got a couple other things we want to share here. Here's the picture that we're showing on the back there of it lit up there outside the OPF. But it was the first shuttle, the second flight, but it carried with it a very important payload, and that was the Canadian arm. And there's our friend Gary Allgaier in the white, in the middle there between Joe Engel and Richard Truly there in their blue flight suits there. Wow, look at all these people staying curious with us today. We appreciate that. Tell us a little bit about the arm and the challenge of that.
Well, that's the most asked question out of the visitor center when people look up there and see that the arm says Canada on it. But in that time span, Canada had the best robotics program. So they were tasked to build the robotic arm. And so they did, and STS-2 was when we first installed the arm and that. And then it performed great in space. It was used to lift payloads out. It was used like when we did the Hubble repair. The arm would reach out and connect to Hubble and bring the Hubble down inside the payload bay, and they would latch it in place while the astronauts went out to do the repair work. But the arm deployed satellites, it captured satellites, and if you don't realize it, the orbiter is the only vehicle that's ever gone to space and retrieved damaged satellites and brought them back to Earth so they could be repaired here or evaluated here. So we learned a lot by having payloads up there that we could go retrieve. No one else has been able to do that. So
Now, Terry, if they couldn't retract the arm, and here's a nice close up of how the arms, if they couldn't retract the arm and safely close the doors of the payload bay, what would they do?
well, and then it has explosive bolts on there, so they would actually jettison the arm,
What?
get it out.
Explosive bolts, right?
Yeah,
Right
yeah,
over here.
Yeah,
huh?
yeah.
The
So
top.
same thing with the KU band antenna. We have an antenna that once they're in space and the payload bay doors are open, the antenna deploys out of the payload bay. And same thing, if for some reason it won't go back in, it's designed to separate so that they can get the doors closed.
Amazing, all the pyrotechnics, explosives that are on just all kinds of devices. and
All
things.
over the place in there. That's why,
Valves are open with explosives.
yeah, that's why, people couldn't understand, well, wait a minute. Yeah, we're not transferring fuel or anything, but we are still a hazardous processing area because of all of the hazardous things we have in there, including when people started getting cell phones. Said, well, you can't bring them in the hangar. Well, why not? Because the electronic signal it sends out, we don't want to take a chance. Only certain radios could be used. There's a lot of stuff you could not even have around there. And when we did the hazardous operations, we not only shut it down to everybody that wasn't part of the hazardous operation, we shut it down to 700 feet around the building. No one was allowed anywhere around it. So it shut down processing in the other bays as well because you couldn't even be close to it. So,
700 feet.
yes.
That's two Ohio State horseshoe fields end to end there. Okay, gee, that's a big distance there. All
Yeah.
right, that
And we put guys in there in what's called a scape suit and then they look almost like an astronaut, but everything's self-contained for them to go
Yeah.
in and work on these. So
we have one hanging in our workers gallery. Marty was certified to be in a escape suit. That's a claustrophobic thing for sure to be putting on you there.
and then, like I said, it's tight working down in there. Now you put that big bulky suit on, and now you still got to go down in there and work. It's a nightmare for the new vehicles they're working on now, where they have to go in there and that. But to protect them, it's just like the astronauts. So their suits are big and bulky and that, and so for them to go out and do spacewalks, it's really a challenge.
Well, we know you've enjoyed the expertise here, Mr. Terry White, a great friend of our museum. We've got Zachary Barnes watching, Doug Miller, Hot Rod Flack is out there watching, Alexander Jordan, J.C. McVeigh, Ashraf Aratu. You recognize any of your friends here?
Not yet.
Why don't you read there with Victoria there?
Victoria Weldon, Philip Terry, nice last name.
Yeah.
Dan Antonio, Brenda Gentry, Steve Noonan, Eric Humphreys, Amelia Evelyn, Matthew Brunald, Raymond Roberge, Dana Healy, Miranda Bassett, Roy Gavin, Curtis Shipley, Rosa Citron, Andrew Ives, Sarah Adil, Charles Phillips.
Cool. I'll finish it
Okay.
there with Charlotte Zan, Steve Hammer, Brad McKinnon, Melissa Pope. She's here, local here. Doug Forrest is in Los Angeles. Rebecca Vicknar.
That's my daughter.
All right, Rebecca. I knew someone would be in there.
Yeah.
Hey, Rebecca. Your dad, his Cajun accent there on Roberge. I like that there. All right. Of course, Tom UCX watching. He's happily retired, munching out with his afternoon snacks there in Philadelphia. And there, Dr. Al Kohler. Hey, good to see you. You know, our Kohler map has been recreated digitally out there at the Space Center. It's right across from the the Orion spacecraft there in the Gateway. JG Top Gun Academy's watching. Lynn Feathers, Madeline Vaughn, Dan O'Damino, Gary Gerald, our favorite peanut farmer, Andrew Oliva. He lives down the road here. Travis White,
And this time, Travis
There's
White,
Travis, your
my
son.
son, he's watching from Baltimore. I mean, he did call in from Iraq
Yes,
when
he
he was
did.
over there because he's an Army major.
Yep.
So yeah,
Glad to have you watching Dad there, Marcia, or Travis, Marcia Follick.
and she worked with me on STS-1.
Did she?
Marcia, yeah, she worked with me a
Alright.
long time out
and
there.
Hadley McIntyre there. Well, we're glad that you all support your friend here. We just can't get enough of what Terry's got to provide out there. So we're always glad that you make time for us, Terry. A question or comment, Marty?
Yeah, Dino Tamano. Had anyone been injured from oxidizer handling on the orbiter?
Yes, they have. So it's mostly just burns to the skin and that. But before STS-1, we did lose 2 techs, but we lost them to nitrogen-enriched atmosphere. They went in before it had been purged. But yeah, no one passed away because of oxidizer or monomethylhydrazine and that. But also, one name on there, Lynn Feather.
Yeah.
She was my admin for many years, and she was a fill-in granny for my kids when they were little. So,
Well, we love that you're watching Lynn here. Terry is used a lot by NASA still to communicate with the public. You've been privileged to have literally given tours to presidents of countries, of politicians of our own country.
correct.
Were you involved at all with the hoopla of the Hollywood movie going on out there last week?
Just escorting people around to make sure they didn't get in areas that they shouldn't go in. So,
Okay.
yeah.
Marty, you were involved with some of that too at the VAB. Marty said that Scarlett Johansson's pretty good looking.
Oh, I didn't get to see any
Oh,
of
you
the
didn't?
people that were going to be in the movie. So yeah.
Oh, well, Marty did. What's
Yeah.
up with that, huh?
He didn't tell
Terry?
me. He didn't tell me.
Well,
But you
geez.
have to know people, Terry.
Yeah.
They Winkle, that's even down at the end of White Winkle. Let's see, yeah. H before I there, yeah. But there's always stuff going on. You've retired, but you're still called upon as a volunteer to do what out there?
Yeah, to escort special guests around.
Mhm.
So, not only dignitaries and that, but military leaders and heads of state and heads of other countries and that. So, yeah, it was interesting to escort Tony Blair and his family around in that.
Tony Blair, the
yeah.
Prime Minister of Britain.
Yeah, and his wife sent me a Christmas card with an invitation. She says, if you're ever in England, come stay with us at 10 Downey Street.
And you tried to effort that, but you had another shuttle to process, right?
That's right.
So-
That's right. Yeah. So.
And, well, Terry, it's just great having you here. We're going to show our last slide here of STS Columbia STS-2 landing. Like I told you when I'm a space geek watching this landing in November 1991 with probably John Zarella commenting about it there. And when you saw it break the clouds and get in the atmosphere, I think a lot of us thought, they're going to make it, because there ain't no way could I think that the wheels wouldn't come out and that it would land there. But the patina on it after 2 flights still is.
Oh, yeah.
Uh,
But you can already see the scorch marks in that
Yeah.
from the heat of reentry. So, yeah.
One final thing, my friend, kind of it's a realistic note and don't want to bring back bad memories, but Terry was heavily involved in the recovery of Columbia after the tragedy of 2003. You saw this bird and all its glory in your garage, and then you're out in the field in Texas one day and you see a piece and part that you saw in your garage.
Yeah. And
I mean, emotionally, I don't know how you kept it together.
well, that's, I used to fly air rescue in the Air Force, so it's a little bit different for
Mhm.
somebody who's never done any searching
But you understand what I'm saying
Yeah.
about seeing something that was so normal to you in your garage, and there it is destroyed in front of you.
Yeah, and the people out there in Texas, like the first crew I went with out to pick up stuff, and I picked up a part, and I could tell them exactly where it came from, and they looked at me like, "Wait a minute, how do you know?" And I said, "I can tell this part by its shape exactly where it came from on the vehicle and that." But to go around and look at things and then convince all the people that I had worked with that had built it and got it ready for all of its flights that Mother Nature can do something like that. We picked up pieces of titanium, and they said, you can't do this to a piece of titanium. I said, Mother Nature can. I mean, it was the thrust structure that supported the engines and that, and it was literally pulled apart. It wasn't blown apart, like an explosive. It just literally ripped it apart. So the forces that vehicle saw when it was coming apart was just, but, the greatest search effort ever conducted in the continental United States. And I became in charge of the helicopter search teams and that. And I had 37 helicopters flying on some days out there recovering parts. So.
And where is Columbia's parts today?
Now, some of them are stored up in the VAB, and special guests or universities that are allowed to go up there and look. They actually loan parts to different companies and universities to study them to help figure out how to make aircraft and future spacecraft even safer by looking at one.
It lives in our heart, in your hearts out there.
It
being
does.
A teaching
It does.
tool
Yep.
for future generations.
Yep.
That's beautiful.
And they're still
That's
finding
beautiful.
parts out in Texas.
Yeah, and they actually found less than half of it, of course, right?
Yeah,
In
yeah.
there.
But the
And,
experts said we would never find 15% of the vehicle. And the last of the stuff that I participated in unloading from Texas, we found over 45% of the vehicle. But if you ever go look at that country, it's a lot of piney woods, lakes, rivers, and that. And, some of the stuff we could tell it had impacted the ground, but we didn't have tools to dig for it and that. So, yeah. So we said, well, it's not an area that we deemed as critical. But, yeah, so.
Well, as hard as it was to take this orbiter and process it the first time, it kept getting better and better and better with as new orbiters were built. I just think it's a tremendous legacy of the American worker and the work ethics, let alone in the space industry.
Yeah, and we came up with stronger tiles. So even for the last flight, we put some of the stronger tiles on to make the vehicle even safer. Even though we knew it was the last flight that one of them was going to take, they said, yeah, take off the weaker ones and put on the stronger ones. We know all we can do is make it better. So.
Do you know any lessons learned in this flow of a shuttle that's been applied to the aviation airline industry, for example?
I don't know. I mean, there's so many things we learned. I know the medical industry has learned a lot by the different things that they've done in space, but any of our processing things, we went around and looked at different things. We went and looked at stuff in Michigan. The GM at their advanced engineering went up there and looked because they have a tool that they use to measure the flushness of hoods and trunks and all that. And they thought we could use it for, it's a mechanical tool, but if we could use it for measuring all the gaps for the tiles and that, because the tile gaps are really critical. In some areas, the gap can be no smaller than 19 thousandths of an inch, but can't be any greater than 30 thousandths of an inch. So you have 11 thousandths of an inch tolerance. But the tool they had worked fine for metal to metal surfaces, but when you're putting it in there with something that's more fragile than an eggshell, it just would not work for that. So. But it was interesting to go in there and see the advanced engineering and the things they had, except they wouldn't let me go out on the track and look at next year's models.
Well, we appreciate you being here. Terry's talking to Larry Pushkar and Dave Stange here, two of our A-list buddies, top viewers of Stay Curious. You've seen them comment over and over. We had them at the beginning of the program here. Thank you guys for being here. All right, Marty, what else we got to clean up here today?
Leslie Day and Cliff Watson are also watching. I said Leslie Day and Cliff Watson.
Okay.
Okay. And
Cliff's
just
in Pomona, Australia.
a minor correction, Mark. STS 1 through 4 was not designated experimental. It was designated developmental.
Okay. All right, good.
That's
Yeah, developmental instead of experimental. Okay. I'll buy that anytime from Marty Winkle because he's one of my heroes, just like you.
He's the
People
one
who are national treasures and done
he's
things
the one
nobody
making
else.
sure we're accurate.
That's right. And he has for 767 episodes, something like that.
And he's
And we
really
love that.
valuable.
That's right. We are. Thank you, Marty, for all you do here today. Of course, we enjoy having Terry White here. He stops in, just not frequently here, and get cleared out here. Maybe you'll do some dosing for us here down the line
Yeah.
there, because you certainly have a lot to share on this program here. I really enjoyed it. Anything you'd like to add about the
No,
beautiful
Except
OV
I won't
102?
Yeah, I won't be here next week because next Thursday I go to meet my new grandson that's coming into the world on Thursday.
All right. Down in the Louisiana.
Yes.
Last time you were there, you brought me some mighty fine Cajun
You can-
gumbo
you can
that I enjoyed.
thank Rebecca for that. So, yeah.
Thank you, Rebecca. I enjoyed it. Very tasty. The remoulade or whatever
Yeah. So
that you all call was just right. The
so we'll have to
soupiness of
see
it.
what they're cooking up this time.
All right. Not too good on crawfish. Etouffee's not my thing, but I dig all the rest of it there. So, well, we hope that you've enjoyed Terry's conversation today about the real first return to flight, STS-2. Tomorrow, we're going to clean up the rest of the week. We'll show you some pictures of the Stangy out there in Pushkar, seeing a rocket launch. Oh, okay. All right. We just lost the audio there. It may have come back. All right. So, well, we're glad to have everybody here, and what a beautiful launch. Come and see us at the American Space Museum, okay? Because we've got great people here that want to share their stories with you, the best artifacts in the world as we celebrate the birth of America's space age right here in this delivery room, Brevard County. So until I see you again, I'm Mark Marquette saying I can't wait to see you to bridge the space between us.
And remind him to show up April 15th.
Yes, April 15th for Shuttle Fest.